Good evening, everybody. Meanwhile, let me give you a simple problem. Find the member forces. Just think about what is the best and quick way without using any writing any equations. How can I find the unknown forces in the members? Don't use pen, don't use any equation, just see the problem and identify without any with minimal calculations how you can find all the unknown reactions or support reactions that are required. Please think of it and just let me know. Take a couple of minutes and let me know. We'll discuss about it. Anita, Priyadarshini, Ramya, Vinod, Vishnu. Do you guys have info about any others?
Sir, I think those people are going to study about JDO, sir. Coming JDO, the next week will be happening.
Those people?
I think they are preparing for JDO, sir. TNPSC JDO exams.
Okay, when is that exam?
Saturday, sir. Coming Saturday.
Okay, Saturday. Then I think you guys can ask for classes after Saturday, it seems, or if it's okay for everyone, because they will miss the continuity and problems might get during understanding. But let's see still. Yes, Anita, you can. I'm just giving you my number. You guys can WhatsApp me if you guys have any doubt. Maybe I may not respond you quickly, but I'll definitely respond to you. Just note it down and don't share. Even if you guys have any grudge about me, plus didn't share to your friends and don't get me trouble. What about this question? I think Ramya are absent yesterday, right?
Sir, yes, sir, but I went through the recording, sir.
Okay, thank you. And what about Vinod? You're also absent yesterday.
Yes, sir.
And Priyadarshini, sorry if you're present yesterday. Are you present?
Yes, sir, I was there, sir.
Yeah, okay, thank you. I think others are present. It's in is present. What about Vishnu? Vishnu, bye. Vishnu. Okay, then. Come on, anybody can explain this problem? Simple test, right? Anybody can take lead and discuss this problem with anybody. Come on. Anybody is interested to?
Or can I, sir?
Yeah. Okay, carry on.
So there will be a horizontal reaction and a vertical reaction at point A.
Okay.
There will be an vertical reaction at point B.
Okay.
So the horizontal reactions will be compensated by the 10 kilonewton, which will be in the opposite direction.
Yes.
And there will be a moment created, and that will be equal to 30 kilonewton meter.
Yeah.
And this reaction, that is the both vertical reactions will constitute anti-clockwise moment, sir.
Okay.
So that will be equal to, I think so, 10.
Okay. Yeah, good. Carry on. Everything is correct as of now.
Okay, sir. And so.
Okay. My first question for all of you is that if I want to find the member forces, do I have to find the support reactions? Is it necessary?
No, sir, not necessary.
If I want to find the support reactions, is it necessary to find the support reactions? I need answer from everybody. As only 5 people are present, I think we can interact, isn't it? So let's just make it as a discussion kind of a class. No need, Anita. Okay.
Not necessary, sir.
Not necessary, right? Now, Can you guys identify what are the zero force members here? What are the zero force members? Are there any members?
Yes, sir. CD and CB.
Vinod, can you please identify what are the zero force members? I think you're absent yesterday. Have you gone to the previous recording?
No, sir, no, sir. I don't have time, sir. Sorry.
Okay, thank you, fine. Vishnu Bhupati, can you? Yeah, as there are no force acting at joint C and two members are connected. So that's why there is no force in this member and there is no force in this member too, isn't it? Now you have left with a joint D, and at joint D this member is already zero force member. Then you are left with member AD and member DB, right? Now first, which equation I should consider to get the reaction? Like if you resolve the forces at this point, if you consider the equilibrium at joint D, and then if you imagine, if you look at the forces along X direction, let us say this is your force along X and this is your force along Y. Now, if you look at about X direction, if you resolve the, or if you draw the free body diagram at point D, then how many forces will exist? At this joint D, if you look at along X, 10 kilonewton will exist, and then
DB.
the horizontal component of DB, right? What about this angle? This angle,
45 degree, 40.
45, sir.
as you can see, horizontal and vertical lengths are equal. Whatever the angle you take, that will be 45 degrees. So along horizontal direction, 10 kilonewton is existing and horizontal component of the force in the member dB, right? Now, imagine, if I imagine, let us say if I draw the free body diagram at point D, if I want to represent dB, how can I represent it? I'll draw a line along the member force, along the member dB, and then if I represent an away from the arrow, this is what the tensile force. If I want it, if I represent towards the joint, this I will represent it as a compression. Now, without drawing anything, you can just imagine, right? Here, if I represent an arrow like this, as you're resolving at joint D, just look with respect to the joint D. If you look at
Yes.
the joint B, then how it is becoming then? It is towards the joint for point B, but it is away from the joint for point D. So
Yes, sir.
that's why whenever you are representing the arrow, please make sure that you are looking at the point where you are drawing the free body diagram. So here with respect to point D, if I look at this arrow, this represents the away from the joint, right? So imagine if you resolve it along the horizontal direction, what do you think? Will it be in the same direction of 10 kilonewton or it will be in the opposite direction?
Opposite direction.
If I represent an arrow like this, if you resolve along X direction, what will be the direction of the component? It will be along the 10 kilonewton or opposite to the 10 kilonewton?
Along the 10 kilonewton.
Opposite. See, whatever the 10 kilonewton force, this whatever 10 kilonewton.
Sorry, sir. Sorry, sir.
And if you resolve it, how much you will get it? This is what your horizontal component,
Yes, sir.
FBD, and this is what your vertical component, FBD, isn't it?
Yes, yes,
So,
yes, yes.
if I represent an arrow like this, that is along the direction of the 10 kilonewton, then it won't balance the 10 kilonewton, isn't it?
Yes,
So
sir.
that's why what I
Yes,
can
sir.
do,
Yes, sir.
instead of drawing the free body diagram, even in the diagram itself, you guys can identify if you guys have much clear idea. So here, instead of drawing the free body diagram, then what I will say, here at this joint, directly I will consider a force like this. Now in this case, what you can say, if you resolve it, then FBD will oppose the force 10 kilonewton. To be in equilibrium, this must be equal to this. Then what about the horizontal component here? If force in the member BD is FBD, if this angle is 45, if you resolve it along X, how much you will get it? FBD,
Cos 40.
here angle is with respect to the horizontal. So here it will be cos 45. Then how about the force in member BD? Equal these two. 10
Uh,
kilonewton must be equal to FBD cos 45. So what is my
Yes, sir.
FBD then? It is nothing but a 10 by
10 by root 2.
cos 45.
Yes.
1 by root 2. That means it is
1
how
by-
much? 10 root 2.
10 root 2. 10 root.
10 root 2. And as my arrow is representing towards the joint, then it represents the compression.
Compression. Yes, sir.
Right? Now, look at along y direction. Along y direction, how many forces be possible at the joint D?
Only one, sir.
Force in the member AD is possible and
Vertical component.
Result
BD.
vertical component. Sir. Yes,
So
sir.
vertical component of BD is in which direction? It is if you resolve it along y
Downward direction. Downward direction.
upward. Don't get confused. And this is what your force in the member. If you resolve it, what is your horizontal component? This is your horizontal component, FBD cos 45. What will be your vertical component?
Yes, sir.
So that's why I'm telling you, don't be in a hurry to get the answer. Just think it while you are saying. It is common that we are eager to find the answer, but just think about it, right? So because of this force in the member BD, if we resolve it in the vertical direction, that will come as upward direction. To balance it, force in the member AD, it should act in which direction?
Opposite direction.
Downward.
Opposite direction.
Isn't it? If you resolve along, but see, I'm not completely drawing the free body diagram and letting you solve it as you guys are doing like your regular courses. I'm just telling you to, this is how you guys have to think and solve it in the exam, any exam. That is why you guys can reduce the calculation part. So if I draw the free body diagram, if you want to represent me, this is what 10 kilonewton. And instead of considering the tension, here directly I will find out the compression force as I already got it. This is what your FBD. And if I resolve it, this is what your horizontal component, FBD cos 45. And if you resolve it, instead of representing here, I'm just representing here for the convenience only. So upward, this is what nothing but FBD sin 45. And again, force in the member AD. As I don't know, I will assume the tensile force. So this is what my force in member AD. So first we have to draw this and you have to see the forces along X, you have to see the forces along Y. Instead of drawing this triangle, that's what you have to think about. That's why I'm telling you. Force in member BD, if it is acting, if the direction is acting like this, if you resolve it along vertical direction, then see the direction, vertical will be. How it will be balanced? It will be balanced by the force in member AD. As this reaction is coming as upward direction, to balance this, it will act in obviously downward direction. Think about joint D. With respect to joint D, this arrow, is it representing away from the joint or towards the joint?
Towards the joint, sir.
With respect to joint D, this arrow
Away from the
the joint. That
Yes, sir.
means
Between.
the member AD is under tension. And what about that component? So force in member AD, that should be equal to vertical component of BD. What is the vertical component of BD? FBD sin
9 45 degree.
Already we know what is FBD. 10 root 2. What is the
10
sin?
root 2.
45.
1 by root 2. 10, sir.
So this is what we have discussed
Yes,
in
sir.
the previous class. If the angles are equal, or you can imagine, as these two members are 0, forget about them. Imagine if you are applying a force like this, obviously what will happen? This member will be under compression. And as this member will be under compression, this member will be under tension. That is how it
Yes, sir.
happens, isn't it? Now, look at this joint, joint A. Already I know what is my force in the member AD,
AD will be 10 kilonewtons.
and that is under tension,
Tensile.
right? Can you please tell me how can I represent the force if I, so point joint D is over. Now what else you remind with? You have remind with only
Horizontal AB
horizontal member AB and then support reaction,
reaction.
isn't
Yes,
it?
sir. Yes,
Now
sir.
Think about it. At joint A, again, if I can resolve or if I draw the free body diagram, how many members will exist? FAD I have to represent it. FAB I have to represent it. Vertical reaction I have to represent it. Horizontal reaction also I have to represent it. Right?
Yes, sir.
So already I know the force in member AD, isn't it?
Yeah, yes, sir.
So if I want to represent that force with respect to A, do I have to represent an arrow away from the joint or towards the joint?
Towards the joint, because that will be creative equilibrium.
It is under force in member AD, it is under tension.
Yes, sir.
If it is under tension, always you have to represent an arrow away from the joint.
Oh,
So at joint A, if I draw it, I will draw a line along the member AD and then I will represent an arrow away from the joint. This is what my force in the member AD. That will be equal to 10.
sir, can you explain now once again, sir?
If I draw the free body diagram at A, this is point A. How can I represent the force in the member AD? What I will do? First, I will draw a line, isn't it?
Yes, sir.
And if I want to represent a tensile force, how can I represent it?
Away from the
Away
force.
from the
Yes.
joint. So
Yes.
if this is my point
sir.
A, what is the away from the joint? Upward direction or downward direction?
Upward direction, sir.
Upward direction. So this is what you are
Yeah.
nothing but your force in member AD. Or C,
Okay, sir.
my member AD, this is what my joint D and this is what my joint A. At joint D, if I want to represent my force in the member, what I will do? Draw a line along the member AD and then represent an arrow away from the joint. So what is the direction of away from joint? Downward.
Downward, sir.
So this is what my force in member AD. If I want to represent in at point A, imagine this is your point A. I'll draw a line along AD and then away from the joint. So this is also my.
FAD.
That
Clear, sir.
means
Clear, sir.
whenever you are representing the forces. So first of all, tell me, these are the internal forces or applied forces?
Internal forces, sir.
Internal forces.
Imagine if this is member AD and if I want to represent an applied force, this is what applied force, isn't it? Let us imagine I am applying, isn't it? This is what my applied force.
Yeah,
Right or
sir.
wrong?
Yeah, sir.
Always remember
Oh,
the direction or the type of action will be represented by using the applied force direction. That means you have to say whether it is tension or compression depending upon the applied forces direction. So because of the applied, you can directly imagine, depending upon this 10 kilonewton force, you can say that this bar AD it is under tension. Similarly, if I represent a force like this, you can imagine, right? What is this type
yes,
of
sir.
force to the bar AD?
It will be compressive.
It will be under compression,
Compressive.
right? So
Yes, sir.
whether it is tension or compression, it will be represented by applied forces only.
Okay, sir.
But you have to find out what is the internal forces generated in the member, isn't it?
Yes, sir.
Now, look at joint A. If you draw the free body diagram at joint A, I'm not talking about just joint D. As I told you, if your entire bar, entire structure is in equilibrium, each and every point and each and every section will be in equilibrium.
Yes, sir.
So just look at point A. And how can I represent the internal force direction? Obviously, opposite to it, isn't it? So
Yes, sir. Yes, sir.
this is what your opposite direction.
So,
Look at joint D. What is the opposite direction to this?
Look,
Towards left.
toward left, sir.
Now you can see these two look like tension.
Yes, sir.
But if you see the internal force direction,
Compressive, sir.
You could not say compression. Those are just the internal forces
Tension.
reaction.
Yes, sir. Yes, sir. Yes, sir.
So
Yes,
that
sir.
is what I'm telling you. Always stick with the, while deciding whether it is tension or compression, you have to
Yes, sir.
decide with respect to the applied forces. So
Okay, sir.
that's why at a point, if you're talking about at a point, that's why I'm telling you, draw a line along the member AD, represent it away from the joint. So that is what your nothing but your representation of a forces in the member AD. Similarly, if you look at point A, draw a line and represent it away from the joint. So again, this is also my representation of force in member AD. The directions might be different. Here it is left side and right side, and here it is left side, but you should follow the representation. Always draw a line away from the joint. Clear?
Clear, sir.
So that is how you guys might have confused that if I ask you to represent a joint, you guys had in downward. But did you find the difference? While talking about this direction, this I have said with respect to point D. Now I am asking you to represent with respect to A. Now tell me, at point A, if I want to represent my force in AD, internal force reaction in which direction? Upward or downward?
Upward will.
Sir.
Yes, upward.
Upward, sir.
Now clear?
Clear,
I
sir.
think previously guys I have some downward or same. So what is this force then? 10,
Sir.
isn't it? Now tell
Yes,
me,
sir.
what will be my support reaction? Here at point A, how many members are connected or how many unknown forces are there? Actually,
3 unknown force.
3 will be there. What are they? Force in member AB,
AB,
vertical reaction
then
at A.
2 reaction, vertical reaction and
Right.
horizontal reaction, sir. Yes, sir.
All of those are acting in perpendicular directions, isn't it?
Yes, sir.
Isn't it right? That means AB, is it have nothing to do with the vertical direction? Force in the member AB, is it have anything to do in the vertical direction?
No, no, sir.
Because there is no component, because it is truly acting in X, isn't it?
Horizontal.
That means this 10, how it will be balanced at A? Whatever the force in the member A,
Vertical reaction.
that will be balanced by the reaction, isn't it? Now tell me, what will be the reaction at A? At point A, tensile force in the member AD, it is acting along which direction? Upward
Upward.
direction. How can I balance
Upward.
it?
Upward, sir.
Downward. By
That
downward.
means my
Actually,
reaction.
first of all, we have to assume an upward direction, so we can solve the equilibrium.
No.
of upward.
Already we know the force in member AD. Force in member AD is how much?
10
10,
kilonewton, sir.
10
sir.
kilonewton. I am just telling you, if I draw the free body diagram at point A,
Okay.
if AD is existing and force in member AD is existing,
Yes, sir.
and the reaction at A is also existing, vertical reaction at A, and horizontal reaction at A is also existing, isn't it?
Yes, sir.
Now this is known. How much? 10.
Yes, sir.
Then how it will be balanced? It will be balanced by,
Reaction, vertical reaction and opposite direction. Yes, sir. Yes, sir.
if this 10 is acting in upward, what will be my reaction at here?
Downward, sir. Yes, sir.
Downward. How much it will be? 10
10
kilonewton.
kilonewton, sir.
But as of now, we don't know about horizontal reaction. We don't know about member force in the AD, AB, isn't it?
Yes, sir.
Now, look at now whole the structure. Only one horizontal force 10 kilonewton is acting in the right side.
Yes, sir.
It will be resisted by which reaction? Horizontal
Horizontal.
reaction at A. Now
Horizontal,
what will
sir.
be the reaction? It will
RA.
act towards the left, as it is right.
AB.
It will
Yes, sir.
act in 10 kilonewton. Now, after this reaction at support at A is known, can you tell me what is the reaction at AB or force in the member AB?
Kilonewton towards right
You can
side.
see
Left, right, sir.
10
Towards right,
kilonewton
sir.
is acting on the left. So, member
Towards
force in
right.
AB that should act in the right.
Towards right,
So
sir.
it will be acting in the right 10. Now, with respect to A, this arrow is representing away from the joint or towards the joint?
Away
Away.
from the
Away from the joint, sir.
That means what is the force in the member AB?
Tensile.
10, sir.
And what
10.
is tensile reaction?
Yes, sir.
You can see there are no vertical forces in the entire structure. That means if you look at it whole structure,
Yes,
just
sir.
like this.
No vertical.
If you look at this whole structure, there are no vertical forces. But at this joint, if this is acting in downward,
Yes, sir.
that means here it should act in upward. Is it clear about the mechanism of this simple truss?
Clear, sir.
Here we have not blindly following the reaction. Only the thing is we have to feel their directions, and we can find out them, nothing else.
Sir,
Is it
can
fine? Yeah. Is it fine that you guys are thinking in the other way?
explain about this.
I think your speaker is on. I think you're not speaking to me, it seems.
Joint B, sir. Can you explain again? Like
At joint B.
opposite of TA.
At joint B,
Can you explain, sir, once again?
which force you need about this one you want to?
That vertical force, sir. Yes.
So let's see. If I take the entire system,
Yes, sir.
right? As of now, I know this force. This is 10, and I know this force. This is 10. Right? If I consider my entire truss, this is what my
Okay.
unknown reaction, let us say, VB. If I consider equilibrium of my entire truss, then what should happen? My summation of forces along X should be 0. My summation of forces along Y should be 0. And also, summation of moment should be 0. Right or wrong?
Yes, sir.
Now tell me, how many forces are there along Y in the entire truss?
Sir, only one, sir, because
Before
10
that,
Newton.
Before that, if I am considering the entire truss, why I am not representing the internal forces in the members? If I'm drawing the free body diagram of entire truss, why I am not representing the internal forces in the members?
Because applied force, they will be considered on the force.
Because this is what free body diagram of entire truss. Now, at how many points you have separated this truss?
4, sir.
No, at how many? See, this is what my original
No.
truss.
Sir, 2.
This is what my original truss.
Okay.
I have removed this support and I have removed this support. That means at how many points I have removed this truss from? I have removed it from these 2 points. As I am removing this support, I should represent the action of this support. What is mean by action of the support? Nothing but a what will be the
Reaction.
or reactions, or what will be the displacement, so on. So that is why I have represented this force and this force. Similarly, as I removed this support, the action of this support I have represented in the form of reaction.
Okay.
Did I cut or did I separate any member in the truss? No, right?
No.
I have taken the entire truss as it is. Only I think I did is I have just removed the supports. As I have removed the supports, that's why I have represented the effect of supports on the truss. That's it. So summation of x should be 0, summation of y 0, and summation of moment 0. As you look into the vertical direction, how many forces are there? 2. 10 is acting in the downward, and VB, it is the unknown force. But if you add these two, how much you should get? 0.
Okay.
As this force is already acting in the downward, then what about this force? If I want to add these two, I should get 0. Based on that, what will be my vertical reaction at? Sorry, I think
Give
it will be upward 10. Now you agree, right?
Yes, sir. Yes, sir.
Okay, then thank you. Let me give you one more simple example.
Yes, sir.
Okay, just try it, okay? Only you have to say me that first, is there any need to directly, sorry,
Sir, please write down joint of the name, sir. Like A, B, C, D.
yeah, sorry. Thank you for reminding. Yeah, we have to just think about simple questions. The first one is whether I can simply find the support reactions or not. You know, right? What is meant by simply?
Sir, no need, sir.
As I told you in the previous classes, by visualizing some of the effects, can you directly find the reactions or not? That is the first thing. And second thing is that, is there any need to find the support reactions to get the forces in the members? That means without finding the support reactions also, can I find the forces in the members or not? That is what your second point. That means without reaction. And third point is, you guys have to identify, is there any zero force members are there in the truss? And fourth point is, it is possible that in some cases, forces in some members will be equal. So quickly, can you identify in which members forces are equal?
First question, no need to find the reaction, sir.
Or can you quickly find the support reaction? Tell me. Without answering second question, just tell me if you can find simply the support reactions. Can you tell me what are those reactions?
Because DC and DB or DE, it's like a zero force member. Is or correct or
No,
not, sir?
let's go one by one. If we can simplify the support reactions with very minimal calculations, can you tell me what are the support reactions?
So the horizontal reaction, sir. 15
Horizontal.
kilonewton
Yeah,
towards left side.
the first
Yes, sir.
reaction you have to represent is
15
horizontally. At which point?
At A point,
At
A
A, sir.
point. What is the horizontal reaction? As you can see, only two horizontal forces are existing. Both are acting on the right side. So I can say this is my reaction. If you can sum it up, 15 kilonewton. Is it clear for all?
yes, sir.
Right? Now, any other reactions? Is there any applied forces? Sorry, any applied vertical forces? No applied vertical forces, right? That means if I add vertical reaction at A and vertical reaction at E, can I say that they will be in opposite directions? Can I? Did you got my question?
Yes, sir. Because there is no vertical load, so
As there
that
are
the
no
both,
vertical loads,
so
if
that
you
the
add
both
reaction,
reactions will be equal
if
and
you add
opposite.
reaction at A and at E, they should be zero. That means as there are no applied loads, if one is acting in the upward, then another should be act in the opposite direction. Then only if you sum it up, they make it up as zero. You guys are not doing any calculations, right? You are just thinking in your mind, isn't it? So that is what required in this code. Now, how can I find those two? By balancing the moment. Now, because of 5 kilonewton, it is trying to rotate your entire truss. In which direction? Because of 5 kilonewton along this line, along the support direction,
Clockwise, sir.
clockwise. And what is its magnitude? 5
15,
into 3.
315.
And similarly, because of this 10 kilonewton, what will be the effect?
60.
Sridarshini, can you tell me what is the effect? Because of this 10 kilonewton, what will be the
Clockwise.
unbalanced moment that will come?
60 kilonewton.
Right? 10 into 3 plus 3, 6. So 60. The total number 75. That means 75 kilonewton meter is the unbalanced moment. Now, how can I balance it? With the support reactions. They have
RA
to
and RE, sir.
RA and RE they should generate which type of movement? Anti-clockwise.
Anti-clockwise.
Question.
If they act in anti-clockwise, what will be the direction of hit A? If I represent it,
Downward.
if I represent reaction at A in upward, then only they will make the anti-clockwise direction, isn't it? If let us say if this is R and if this is also R, then what about the anti-clockwise movement that is generated because of this R? R
We
into
are R into 3.
E sir.
R into 3.
3
Then
Sir.
it
equal
should be
to
equal to,
75. 75.
then what will be my R? 75 by 3. How much it will be?
25.
25. Have you guys used calci for telling me this value, or you guys just said like this?
Sir,
Uh,
25.
Yeah, it is 25, that's right. But my question is silly point, I'll tell you here. Have you guys used
Without calculation, sir.
Without
Without
calculator?
calculation.
Have you guys gave any competitive exam?
No,
As of
sir.
now,
Not allowed, sir.
nobody
Yes.
has given. Can I tell you what I have verified during that exam with calci?
Without calculation, sir.
I have verified this using calci during GATE exam. How silly is it? What is the answer? 0, right? 2 times 0. But still during the exam I have used it. But that's what our mind will be like during the exams. Even though we know
Yes.
some things, in a hurry or to get or to avoid the negative marking, we will still use calculator, but that's insane actually, because that you have to avoid it. You have to avoid it by using with practice only. Without practice, those things will not be avoided. Those are simple, right? 2 into 0. It's not simple, it's just sure that it is 0, or 1 into 2 is 0, or 1 into 2 is 2. Just like these things, we should not be doubt during the exam. Those things can be avoided while with a lot of practice only. My point here is that there are some things you are very well known about it, but because of the exam, we might even get those things. Whether it is right or not, that is what our mind will work. To avoid that, stress out the things. These parts we cannot stress out, but if you are remembering the formulas, don't just try to like so on, so on. So at every formula, wherever it is positive, wherever it is negative, inform to yourself that okay, this is plus while by hearting them, this is minus, this is plus. If you tell to yourself, then only you won't commit mistake. Something mistake in the sense in the exam you will not get a doubt. Okay, whether it is positive, negative, those type of things will not be repeated. Okay, let's move on to the problem. It's clear, right, for everybody? So let us wind up this. First thing is over. Now, what about the second thing?
Without.
Is there any need to find the support reactions, to find the member forces? First question we have already answered. So let us forget about what we have found just now. Let us imagine that you guys have not solved for support reaction. Now the next question is it required to find the support reactions to get the member forces? No need, right? Then, what about third question? Any zero force members are existing? Any zero force members? I need to hear from everybody. Most of the times, Anita, Vishnu, or Ramya,
BD, sir.
BD, right? Why? Because
Non-coordinate, sir.
why? Because the force in member BD is 0.
It
The
is
diagonal
non-coordinate.
force will transfer to the incline B, sir. So that will be BD equals 0, sir. No force acting on the member.
No. Can you please come again? What you said?
Two
It is
members are
not
connected
linear.
in concurrent manner and without loading. So non-concurrent member will be equal to 0.
Who- Who spoke earlier before Priyadarshini?
Before myself, Anita was saying
Anita,
something. Sir.
can
Yes,
you
sir.
please?
Yes, sir. Yes,
Please,
sir. Yes, sir.
please complete your thing.
The joint B at the load 5 kN that transfer to the BE, sir.
BG, okay.
And another kind of thinking DB that will be third concurrent member. So that will be 0, sir. My thinking.
Okay. What about others?
Yes, sir. The 5 kN horizontal force acting through the horizontal line only, like BD. So the BD will be 0.
You said 5D is acting along horizontal BD. Then it
No,
should carry some force according to you. What is the thing you have said? Okay. Let me hear any other possibility, any other explanation that you guys want to give it to me.
no,
It
sir.
is a non-collinear force, so it is 0, sir.
Yeah, whoever they give the explanation, that's fine. I just want to hear from others.
That
That's
is
what
one
I
of
meant.
possible way. Then another kind of on the
Yeah.
5 kN acting on the horizontal manner, that joint B. So it will be transfer on the load with the B cell. So
Yeah. Okay. Understood. I need to give option to others who haven't spoke about this. Who didn't spoke about this? Andal Guru, am I correcting? Am I spelling? Am I correct? Am I spelling it right? Okay, Andal Guru, right? Sorry if I pronounce it incorrectly. Just let me know. No load acting at joint D. Okay. See, the point is, first of all, tell me. Let us imagine if I find the force in member BD by drawing the free body diagram at B. First, I did so. Forget about whether it is possible or not. I have found the force in member BD by considering the equilibrium at joint B. After that, I found the force in member BD by using the equilibrium at joint D. Tell me, these two will be same or different?
both are same, sir.
Both will be same, isn't it?
Yes,
There
sir.
is no doubt about it for anybody, isn't it? It doesn't
Yes, sir.
matter. It doesn't matter how you will solve it. At the end, the answer will reflect you the same value.
Yes, sir.
As the answer will reflect you the same value, what you guys have to see? You guys have to see the least possible way to find the forces. Now, to find the force in BD, either I can look at joint B or I can look at joint D. If I look at the joint B, how many members are connected?
4, sir.
4 members are connected, isn't it? Then, can we apply any one of the logic that we have discussed in the earlier classes, like 2 members are collinear and non-collinear member, there is no forcing at the joint, then non-collinear member force will be equal to 0. Or if there are 2 members are acting at the joint, if there are no loads, then force in those members are equal to 0. Any of those points are possible at joint B?
No, sir.
No. But if you look at the joint D, how many members are there? 3. BD, CD, and DE. As these two are collinear, and if you look at this, there is no other force acting along the direction. That's why force in the member BD is equal to 0. Do not always think or judge it by arrangement of the members. Why? Because as you guys are saying that at joint B, as 5 kilonewton is acting, this might be taken care by BE, or those kind of things are not the proper explanation. You guys can say whether they can be under compression or tension, but you guys can't say what about the portion of the load that will be taken care by the members. That means how much percent of this 5 kilonewton will be resisted by this member, will be resisted by this, or will be resisted by this. By looking at only joint B, always remember, whenever you want to find the forces, at once you have to look at only one joint. If I look at joint B, I can say that this is under compression. See, I can say this is under tension. And this might be under compression, that I can say this can be under tension or compression. But by looking at the joint B itself, but I don't know what portion of the load will be satisfied by these force. But if I look at joint D, I can say that the force in member this is 0. So do not always say that this might be taken care by inclined member, this can be taken care of that things we should not repeat in the exam. Have you guys got it? It seems, right?
Yes, sir. Clear, sir.
Yeah. Only guys can say whether it is compression or tension, but always look at only one joint. Now tell me. Force in member AD is equal to 0. BD is equal to 0. Now, can you tell me or can you identify the members in which the forces are equal?
Sir, CD and DE,
Yeah, yes, sir. CD,
CD and DE.
because it is
Why they will be equal?
Sir,
Opposite
the 10
direction, sir.
kilonewton, 10 kilonewton horizontal component will be taking care of BC, but the inclined forces, vertical component will be taking care of CD. So as the BD member is 0, so the force should be taken care of DE. Am I right, sir?
As we are talking about zero force members, obviously that we have to look at it from one joint. If I look at joint C, if I resolve or if I draw the free body diagram, I can tell about this member or I can tell about this member. But if I look at joint D, as this force is already 0, but how many other forces are existing? Member CD, if I represent the force, if I assume it is in tension, this is what my representation of the force in member CD. If I represent the member force DE, if I assume it is under tension, this is what my representation of the force in member DE. As this joint to be in equilibrium, these two forces must be, if we add these two, then they should be equal to 0. That means if this is acting in upward direction, this should acting in the downward direction. Now, this force is nothing but a tensile, and this force is also nothing but a tensile. So, if there are two collinear members are acting at any joint, and then along the two collinear members, the magnitude of the force will be same and they will be also in the same direction. That means if FDC is under tension, FDE must be also under tension. Clear about these 4 points?
Clear, sir.
Now,
It's only applicable for linear, collinear moment only, sir.
those are applicable for?
Only for collinear member.
Yeah, only for collinear members. If they are in not collinear, then what will happen? It won't be applicable. Why? Because the forces will not act on the same line of action. If they are not acting on the same line of action, then it won't be possible. Now, without wasting much time, quickly, again, as I'm giving you the equal distances, so for the simplicity, I'm giving you the equal distances, but in the exam, it might be with some angle, okay? But to give you the clarity only. Do not use calci, do not write any equation in your book, do not write anything. Quickly tell me, what will be the direction of the force in the member BC? Is it under tension or is it under compression? How can you see it?
Under tension, sir.
Under tension?
BC is under
BC
tension,
under
sir.
tension. CB.
Everybody will agree that BC is under
Yes, sir.
tension.
Agree, sir. Agree,
Yes,
sir.
sir, yes,
sir.
Tension, tension member.
Why? Because at joint C, if you look at this,
Away from the joints.
as 10 kilonewton is acting on the right side, the horizontal component of BC should act along which direction? Left side. To get that, we have to represent an arrow like this. Then only if you resolve this, the component will be on the left side. Now, what is that value? Do not use calculus. If you resolve this component, then what is if this angle is 45, right? Horizontal and vertical angle are same. Then what is the component along horizontal direction?
Sir, 10 root 2. 10 root 2, sir.
Yeah, 10 root 2. This is FBD. FBD cos 45, that should be equal to 10.
Yes,
10
sir.
by cos 45. That means without doing any calculation, I can say that this is 10 root 2. Now, what could be the direction of member force CD at joint C? If you resolve this force, it will be acting in which direction?
Down, CD,
Down.
CD, sir.
If you
downward,
resolve the
sir.
member, if I resolve the member force BC
Uh,
along vertical direction, that will be acting in the downward. Then what will be in the member force CD?
oh,
If
Sir,
it is
same
acting in
10.
the downward,
the same, sir, same.
10
should-
kilonewton, sir.
yeah, it should act in the upward direction. Is it okay?
Yeah.
First of all,
Yes,
direction.
sir.
First of all,
Yes, sir.
direction it will be in the.
Yes, sir.
How it will be downward? Are you talking about BC or CD? Vishnu, you are talking about down means you are talking about member BC or member CD. Or now you are getting in ambiguity, or you don't know the answer. Yeah, you just look it. Just tell me it's okay, it's fine. Can at least respond, please. As you sat down, you are mean for which member? FBC or FCD? CD. Can you think why it will be downward? If you imagine a joint C, this is what your member BC. If you resolve this force along vertical direction, this will act in the downward. This is what your FBC sin theta, because the angle here I consider is with respect to horizontal. To balance this, member CD should act in which direction? Obviously, it should act as it is downward. To balance it, that should acting in the upward direction. Is it clear, or still you need some more explanation? Be free to ask any doubts. Don't carry forward it.
Yes, sir. Clear, sir.
That means this is FBD sin theta. FBC already know 10 root 2. Sin theta you also know sin 45. 1 by root 2 gets cancelled. Then what is this value? 10. What is the force in member DE? This is also
Same as that, sir. 10
10.
kilometer.
It is under tension.
Sir.
Now how many left with? We left with BE, we left with AB, we left with AE.
AE.
Right? Now, if I look at B, total tell me how many forces are there?
Forces.
Total forces. I'm not talking about the unknowns. Total forces.
5, sir.
5, sir.
Total forces.
Total force.
BD is already 0, right? If
Yes, sir.
BD is already 0, then why will you represent it? You don't.
4, sir.
How many are there? At B,
1, 2, 3.
5 is existing. FBC is
And
existing.
FBC, FBA,
FA is existing. FAB is also existing.
yeah, sir.
Now, if you write down the equation, summation of x equal to 0, how many forces will come into picture?
2, sir.
3,
Only two?
sir.
How
3,
will
sir.
it?
Component
Three,
because
sir.
of this. Component because of
Sorry,
this.
sir.
This component.
Horizontal force. Yes, sir. Yes, sir.
Similarly, if you resolve or if you see summation of 0, then how many components will exist?
1, 2, 3.
Three,
3,
sir.
3, sir. 3, sir.
3, right?
Yes, sir.
Because of this, because of this, because of this.
Yes, sir.
That means just like we have found at C or just like we have found at D, are we getting the unknowns in a simplified way? I mean to say that if you write down the equation, that equation will be, this is known, right?
Yes, sir.
This is
Yes, sir.
also
Yes, sir.
known, isn't it?
Known. Yes, sir. Yes, sir.
So if you write down along x direction,
I think
what you will get?
only-
Your equation will be in terms of FBA plus in terms of 5 kilonewton plus in terms of FBC. I'm not exactly representing the directions, but I mean to tell you is that how many
Yes.
components or how many values will be there if you take summation fx equal to 0. Similarly, if you
Okay.
take fy 0, then how many will be there?
3.
This force will
FB,
come. FAB will be there
EEBC.
FB,
plus
FB,
FBC will be there plus
FB.
FBE will be there,
Yeah. Yes, sir.
right?
Yes, sir.
But if you're a smart person, then I won't choose at B. Why? Because as the column calculations are increasing. So
Yeah.
instead, what I can do, now I can think of my support reaction. Why? Because even though at joint A, how many forces will exist if I draw the free body diagram?
Mm.
If I draw the free body diagram at joint A, how many forces will exist?
4,
sir.
sir.
How come 3,
4,
Vishnu?
4.
4.
4, sir. 4
Four.
horizontal vertical reactions and 2 member connected.
As we have
AB.
already discussed,
Yeah.
this will be 15. This will be
20,
downward 25,
25.
and this will be upward
Yes, sir.
25. Now, at joint A, you can quickly find out force in AB, isn't it?
Yes, sir.
Now tell me, if I look at joint A, what will be the direction of my member AB?
25, sir.
25 here it is in downward. To balance it,
Upward, sir.
obviously
Upward.
it will be in
Upward,
upward.
sir.
So upward 25. Now this is tension or compression. You're looking at joint A, it is away from the joint.
Tension.
Tension, sir. Tension.
Similarly, look at horizontal direction. 15 is acting on the left
15.
side. At A,
Left,
it should be
Right
right side.
15.
right side.
Again, with respect to A, it is away from the joint or towards the joint.
Away
Away
from the
from the
joint,
joint.
sir.
Then again, it is
Tension.
under tension.
Tension, sir.
Now you left with how many?
FB, sir.
2,
Yes,
2, P.
FB, isn't it?
Yes, sir.
Now
Yes, sir.
look at joint E. If you resolve forces along X, how many components will come?
X 1, sir.
How many components?
Sir.
I'm not talking about unknown forces. How many
Okay.
components?
2, sir.
1,
Two,
2.
Because of the
Yes,
BE
Yes,
and
sir.
because of the AE.
Yes, sir.
Along vertical, how many will come?
Vertical.
3.
3. Because of DE,
Sir.
because of this 25, and because of the BE. How many unknowns will be there? Only one, isn't it? What is it?
B.
B only, sir.
So if you resolve along X, 2 components will come. If you resolve along Y, 3 components will come. Which one you will choose?
X 2 components, sir.
Because it is what the easier way, right?
Yes, sir. Yes, sir.
Now, let me represent the force in member AE. Now tell me, if I want to represent force in member AE at joint E, in which direction I should represent? Left side or right side?
left, sir.
Now I am done with A. Now I have moved on to joint E. At joint
Left
E,
side.
if I want to represent the force in member AE, in which direction I will represent? Towards left or towards right?
Towards left.
Towards left, sir.
Everybody will agree?
Yes, sir.
Yes,
Now,
sir.
now this is towards left. Now tell me, in which direction or which type of force will exist in BE?
Uh.
Or at joint E, AE is acting on the left side. And BE should compensate, isn't it?
Yes, sir.
At E, how many forces are coming? If you look at along X direction, FAE will coming into the picture. And what is another force? Because of the inclined nature of the member BE, if I resolve it,
2
horizontal component will come,
vertical
vertical
component.
component will come. Because of the ED, is there any horizontal component will come? No. DE is acting truly along vertical direction. So you don't have any
Sir,
component
sir.
along X. Yeah.
Sir, sorry, sir. Sorry for interrupt. Sir,
Yeah.
please make on separate slide. On drawing on the joint E only, sir.
Joint E, you want to draw a complete diagram?
Separate, sir.
Yeah, sure. So at joint E, let me represent the forces. Now I know the support reaction. 25.
Yes, sir.
I know the force in member ED. It is also under tension. I have drawn a line. I have represented an arrow away from the joint. 10. I know the force in member AE. Again horizontal, left side. 10. Only the one unknown is BE.
Yes, sir.
Let me assume that it is under tension. If we assume it under tension, this is how I should represent.
B.
As of now, clear?
Yes, sir. Clear, sir.
Now, look at about equilibrium of this joint. That means summation effect should be 0. Summation effect should be 0. Now, along X, how many components are coming into the picture?
2.
2, sir.
What are they? 10.
FB, sir.
FB.
Then FBE.
Right.
Yes, sir.
If you add them, that should be equal to 0.
Yes, sir.
Right?
Yes, sir. Yes, sir.
As 10 is already acting in the left side,
Yes, sir.
FBE, the component of FBE, it should act along which direction?
What's the point?
Right, sir. Towards right.
10 is already acting on the left. To
Yes, sir.
balance it, the horizontal component of FBE
Towards
should
towards
act
right.
on the towards
Right.
right.
Yes, sir.
If I represent a tensile force, if I resolve it along X, in which direction it will come? Will it come on the left or will it come on the right? As
Sir, what did you say?
initially I have assumed it as a tensile force, isn't it?
Yes, sir.
Now, if I resolve this component, in which direction it will come? Towards left or towards right?
Towards right, sir. So that will be compressive force.
No. The question is,
Uh,
as I have initially assumed that portion member BE is under tension. As of
Okay.
now, clear?
yes, sir. Yes, sir. Clear, sir.
Now, if I resolve this component along X direction, what is the direction you will get it?
Left side only. Sir.
Left
This
side,
is
sir.
theta,
Left side.
left side.
Left
That
side, sir.
means, is it right?
Yes, sir. Yes, sir.
I mean to say that as 10 is acting on the left, if I resolve FBE, it should act along the right to balance it.
Yeah, sir.
But as initially I have considered as a tensile force, it is coming acting toward left side. That means my assumed direction is right or wrong?
Right, sir.
Correct, sir. Correct, sir. Right, sir.
I think you guys forgot about the representation. No, let us forget about it. Imagine if this is my portion member BE. If you resolve this, what you will get? Tell me.
Actually, wrong, sir. Should be in opposite direction towards.
Yeah, that's what I mean to say.
Yes, sir. Yes, sir.
If I resolve this, I'm just drawing here, just for the simplicity. This is what my component, FBE.
Yes.
Imagine the angle is with the
Towards
horizontal,
right.
cos theta, and this is what my component, FBE, sin theta. 10 is also acting on the left. FBE
Yes,
cos
sir.
theta is also acting on the left.
So not in equilibrium.
But
So,
if I want to make it 0, is it possible if I consider it as a tensile force, the both are acting on the left side? That means
no,
if
not
you add
possible,
both, you
sir.
won't get 0. That
Yes,
means
sir.
member force BE, tensile force, if we assume it, that might be the wrong thing. Because if you add those two, you're not getting 0. Then what you should do, instead of considering tension, what you should do, you have to consider it as a compression.
Compression.
Like this. If you
Yes, sir.
act in compression, if you resolve this component, the horizontal component will be right
Global.
side and vertical component will be down. Now you got it? So instead of drawing all these things, every diagram and looking at it, now that's what I'm telling you. If you look at this point E, along X direction, how many components will participate? That is what my first question. Let me come back to the original diagram. At point E, how many components, if you resolve the forces along X direction, how many components will exist? Can I say force in member AE and can I say force in member BE?
So 2 forces.
Two
Only 2
forces.
forces along the X direction, right?
Yes, sir.
Out of these 2, which one we know? Which one we have already known?
A
FAE.
is there. A is sir.
FAE, right?
FAE.
FAE is acting along which direction?
Tension.
Tension
Tensile.
side.
It is tension, but if I resolve the equilibrium at joint E, it is acting along which direction? Left side.
Yes, sir.
Yes, sir.
To balance the forces along X direction, FA is already acting on the left.
Yes, sir.
Then FB should act along which direction?
Right side,
Right.
sir. Because it will
Should
be
acting
created
along
an
the right
equilibrium
side
towards right, sir.
direction.
Yes, sir.
That's why I'm telling you, from this diagram itself, to balance this force, the component of FB, it should act along the right side direction.
Yes, sir.
That's why here itself you can imagine that if I represent an arrow like this, then only this component will act on the right side direction. Then you can say it is under compression without drawing this entire diagram and then writing the equation.
Clear, sir.
Clear? Any doubt?
No doubt, sir.
Clear, right?
Yeah.
Everybody?
Yes,
sir. Clear, sir. Clear, sir.
Are we taking so much time, or at least are you getting in a thinking in a different way? It's fine, right?
Same, sir.
Yes, sir.
Yes, sir.
Don't think that we are wasting half an hour or 1 hour on the same problem.
No, sir. Time is not at all, sir. That's
Thank you.
concept will clear.
Now just tell me about this. This is very simple problem, and let us say this is 3 meter, and this is also 3 meter, and let us say this is also member. Do not think that this is some another member. This is also a member, truss member. Now tell me, if I gave you this problem, just think about how you will approach to this. How you will approach to solve this problem.
First of all, we
No. See, again I'm telling you, don't immediately respond. Just
Okay.
take few minutes, think about it and tell me.
Sir, first I will try to find the reaction, sir.
We will try to find the
Reactions at A and C.
Is it okay with everybody that she will find the reactions?
Then I will move on to the point C.
Okay, let me confirm with others. What about the others' take on this?
Sir, directly we want to go to find the reaction, sir, because
Yeah, let me talk about others too. Whoever spoke as of now? Who said, can you please? As just now who spoke about it? Priyadarshini, are you or Anita?
sir, me, Anita, sir.
Anita, okay, let me. Okay, just a second, guys. Just think about.
Sir, I have to find the 0 force first of all.
Yeah.
Yes, guys. What about others' take on this? Anita said, first she will find the support reactions. What
Sir,
about
I have to
others?
find from 0 force, sir.
0 forces. Is there any
There
0
will be-
forces in the truss?
No, sir. No, sir.
Yes, sir. Zero force on this member, sir. Because BD will zero force member.
No, sir, BD cannot be zero.
Why? Why, sir? BD will be damn sure it will
Cool,
be
cool,
BD zero.
cool, everybody cool. Now think about how many guys will agree that force in member BD is zero?
It's not zero, sir.
Not zero. Ramya?
Yes,
You're-
sir.
Okay, fine. How about others?
Not zero, sir.
Not
Not
zero.
zero.
Okay, fine. Priyadarshini, not zero.
Not
Vinod?
zero, sir.
Andal
Yes,
also
sir.
not zero. Vinod, what about you?
Zero, sir. I said already. Zero.
Okay,
Not
zero.
zero. Sorry. Sorry, not zero. Sorry, not zero.
Anita,
Sir, me only zero, sir.
what is the condition we have talked about? Two members should be collinear, third one should be non-collinear, and
Yeah.
there should not be any force at the joint. Always remember, there should not be any force at the joint. But you
Sir,
look at joint D.
I'm sorry, sir. I'm not focused at
Yeah, fine.
joint D.
Okay, if I am there in your position, I can say that without finding support reactions also, you can solve this problem. How many guys will agree to this? Will you guys agree or not? I can be wrong also. Think about it and tell me.
Sir, I don't think it is possible, sir. We need support reaction for this case, for this problem.
Okay, noted. Under
From my side, sir.
okay, fine. Under
Sir,
your
I agree with the analysis, sir.
okay. Others, Vinod.
Yeah, me too agree with that, sir.
Okay, Sridharshini is also agreeing. Fine. Vinod.
Yes, sir. I'm thinking about it, sir.
Okay, good. Ramya.
I think at point A or B, we can use method of joints. That is, using equilibrium conditions, we can find the forces, sir.
No, I think you're not clear. You want to go, you want to start from either at A or at B?
So 1 minute, sir.
Yeah, okay, think about it, no issue. If you guys are not clear, just let me know that you guys are thinking. That's completely fine.
I think we can go from A, sir.
At A, how many unknowns are there?
Three unknowns, sir.
3 unknowns are there, sir.
Three.
Horizontal reaction is 0.
Is it everybody will agree that horizontal reaction at A is 0? Everybody will agree that horizontal reaction at A is 0.
No, sir.
Yes, sir.
No, sir.
Do
No,
not
sir.
guess it. Do not guess it. Think
No,
about
sir.
it.
No,
And tell
sir.
me.
Because
Because
in this problem, I'm only acting on force vertical direction. So
so
So there is no load in horizontal direction, so it is 0.
0 or not? You have started with no, but you ended up with 0.
no, sir.
No,
Zero,
sir. No,
no
zero.
zero, sir. No
0.
zero.
I think, yeah,
The
everybody is
inclined
right that,
component member may be there, sir.
yeah.
There
If I
is
look
no
at,
external
yeah,
force.
Sir,
No.
if I look
sir,
at the
cannot
end,
directly say that horizontal force will be 0, sir, because inclined member acting on it. So there might be chance on this horizontal direction, sir.
no,
Direction, sir.
no. Always two things you guys should be clear about is, first thing, whether you are looking on the entire structure. Second thing, you are looking at a particular joint or section. While talking about support reactions, first thing you guys have to look at about entire structure. Entire structure means like this. Now I have to see the reactions here, VA, HA, and then VC. So this is what the first thing. If you are talking about support reactions, look it upon entire structure. If you look at an entire structure, any horizontal forces are acting except HA.
0.
No, sir.
HA is equal to 0. So there is no horizontal reaction. The point you are saying that there may be a horizontal component
Due to member forces.
A due to member force AB, but that can be balanced by AD also.
Sir, could you explain once again, sir, please?
See, this I have considered the entire truss, is it right?
Yes, sir.
Now, if I look it on the entire truss, any applied force along horizontal direction?
No plate force, sir.
That means what about this force?
0.
0. This is what I have looked it upon entire truss, isn't it?
Yes, sir.
Now, if I look at joint A, if I'm talking about member forces, means we are talking about inclined force in the member AB, that means you are talking about at joint A. At joint A, FAB, at joint A, FAD will come, and also there will be vertical reaction. You
Yes,
are
sir.
saying
Yes,
that-
sir. Now,
Yeah,
now it's clear, sir. Yes, sir.
Yeah, clear?
Yes, sir.
So
Clear.
it's good that you guys have got and you guys got clear. The more you raise it out, the more you will get clear and the more will be the transparency. Okay, now coming back to the question. Is it necessary to find the support reactions?
Yes, sir, it is necessary.
It is necessary.
Sir.
No need. Yeah, Vishnu, please. Vishnu?
So might be he will type.
Vishnu, you said no need. Can I expect some answer? Why it's not needed? You're also saying that they are needed. Okay. I think everybody is giving the same answer. What do you think? You guys are all right?
Sir.
No, sir. If we start from A, I think it is not necessary, sir.
Why?
Because the horizontal, if we take the point A, the horizontal component is 0, sir. So that the
Okay.
member AD forces also will be 0, sir.
No, that's why I'm telling you. You're looking at joint A.
Yes,
At
sir.
joint A,
2 member will
along
be there.
X direction, AD is there. And what about AB?
Yes,
AB
sir.
component will also come into the picture.
Yeah. Yes, sir.
Then how come you say directly it is, if there is no AB, then you can say. Is it
Sir,
clear?
but that AB component, if you resolve it, it will be in AB cos theta, sir. So AB cos theta plus AD will be equal to 0, sir.
Yeah. Then if AB is
That
positive,
would
then
be
AD can be negative.
AB cos theta equal to minus AD. That would be present, sir. So cannot 0.
Cannot 0. That means both are unknowns, right? At this stage.
Yes, sir.
Yes, sir. Yes, sir.
Now quickly in this diagram, I can tell you that one member force, I can quickly find it out.
Joint B.
BD member force we can find it, sir.
Yeah, if you look at it BD, how many forces will exist at G? If you draw the free body diagram at D, how many forces will exist?
Forces.
1, 2,
At
3,
D,
4.
is it question clear? If I draw the free body diagram at D, how many forces will act in the picture? How many forces will come? Or how many forces you will represent there?
4, sir.
4, sir.
Like
Oh,
that's
right.
DA, DC,
20,
B, and
AD,
20.
DC, BD. Now can you observe one thing? AD and AC, they are truly along X. BD and 20, they are truly along Y.
Yeah.
Now, what is the force in member BD then?
BD also 20.
Along Y direction, if you want to balance it, 20 is acting in the
20, sir.
downward. 20.
Yes, sir.
Tensile or compression?
20 tensile, sir.
Tensile, sir. Tensile.
Tensile, sir.
Tensile. Now, 20 tensile is done here. Now, let us come to the joint B. If we resolve it, what is this force here? FAB.
B.
If I resolve this, what is the force
BC.
here? FBC. And if I consider this force, 10 kilonewton. And BD I know already.
Yeah, B. Yes, sir.
What is it?
20.
Tensile.
Tensile.
Now, at joint B, how many forces are there?
4.
Unknown forces.
Unknown forces 2.
How many equilibrium equations we have?
2.
Summation of x equal to 0.
Summation F equals 0.
Two unknowns are there, two equations are there. Then can't I find these two unknowns?
Sir, what
Can I or
did-
cannot?
Sir, what did you say, sir?
I am having two unknowns, right? FAB and FBC.
Yes, sir, yes, sir.
And I am having two unknowns, two equations. What are they? Summation of x is
Summation fx equals 0, summation
Summation
f equals
f
0.
Now tell me, if I consider the equilibrium at joint B, can I find force in AB and force in AC? Can I find or cannot?
Cannot, sir.
We can.
Okay.
Two unknowns are there. Two
We can,
equations I
sir.
am having. Why can't I find these two? Can anybody
Because-
please tell me why can't I?
The two unknown, sir. Can I find, sir?
You can, right? Obviously, that's what the mathematics
Because
says.
two unknowns and two equilibrium equations. So
Imagine,
can I find, sir? Possible.
imagine. What about this angle? Can you tell me?
45, sir.
45. What about this angle?
45, sir.
45. Now, what about this angle?
45, sir.
If this is 45, 45. What about this angle?
45.
Now tell me, this is 45, this is 45. Resolve the forces along x. What you will get it? Here, resolve the forces along x. What you will get it?
20, 20.
Along x direction. Do not get
X
confused. Do
direction.
not get tension. Do not be in a
Yes,
hurry
yes.
to say the answer. With cool mind, tell me. Along x direction. Arey Papa, what happened? Did I ask this very big question or what? I'm
Sir,
just
not at all.
asking you to look at the forces along x direction. Because of this component will come, because of FAB.
Maybe, sir.
First of all, can I ask you why you guys are in ambiguity? This is the first question that I want to ask you to right now. Why
Sir,
everybody is
FAB.
silent? No,
Sir,
forget,
FAB.
as of now, forget about the resolving forces at B. Why you guys kept quiet? Is there any ambiguity in the
Sir,
process that we are going?
please say once again in your question, sir. I
Sorry,
cannot.
Anita. Can you please say again? I could not hear you.
Sir, what question you have to say, sir?
Okay, okay. At joint B, we have drawn the free body diagram. And I'm telling you that we are having two unknowns. We are having two equations. The first question is, we can solve or not.
Yes, sir.
As there are two unknowns
Solve,
and two
sir.
equations, we can solve it. As somebody
Yes.
said no, I just want to show them why we cannot. Now
Yes,
tell
sir,
me,
we can solve, sir. We can solve.
We can
Sorry, sir.
solve.
now tell me, what about the, now tell me this equation, summation of forces along x. Now, right now I'm going in a very classical way of doing just like in exams. Now tell me, if you resolve it along x direction, how many you will get it?
Sir, FAB
FAB
cos 45 degree plus
45.
FBC cos 45 degree.
Not plus, minus.
Minus, sir. Like one will
Let
be
us
plus
say if
one.
it is acting on the right, let us consider it as positive. Can I say this is what my
Sir.
equation? Minus FAB
Cos 45.
45 plus
Yes.
FBC
FBC.
cos 45 is equal to 0. From this, what I can understand?
FAB equal to FBC.
FAB equal to
And
FBC.
yes, sir, yes, sir, yes, sir. Both are equal.
Now, what about force along y?
Force along y.
Let us say
That's
upward
why-
force is positive.
10
Sir,
minus 20
10 minus 20. Yes, sir.
minus FAB sine 45.
Plus FBC sin 45.
No, minus
Oh.
FBC sine 45.
Sister.
Downward. Both are downward, right?
Both are downward. right?
Yeah. Yes, sir.
FAB and FBC are equal, right?
Yes, sir.
Sir, I have one more doubt, sir.
Yes, please.
Sir, at the point B, there is two forces, known forces, 10 kilonewton upward and a 20 kilonewton downward.
Hmm.
So the governing direction is downward direction.
Hmm.
So the component of FAB and the FBG should be the upward direction, right, Nasa, to compensate the downward direction force.
Yeah, right. You're completely right. And that's what I'm gonna tell you in the next step. But as we're going into the classical way, let's just solve it. And let me tell you one more point too. Now go on. FAB and FBC are equal. If I simplify this, how much you'll get? These two will add, isn't
0
it?
minus 10, sir.
Minus 10. If I take it to the right side, 10. And if you add these, how much I will get? As both are equal, I will say
Yes, sir.
minus 2 FAB sin 45, isn't it?
Yes,
FAB
sir.
and FBC are equal. If I add these to minus 2 FAB, that will be equal to 10 minus 20 minus 10. If it goes to the right, positive. And here you are having negative. So if I remove this negative,
5 root 2, sir.
or if I imagine if you take FAB, FBC sin 45 to the right side, 2 FAB sin 45, that will be equal to minus 10. That implies what is the value of FAB?
FAB will be minus 5 root 2, sir.
Sin 45, 1 by root 2, root 2 times. What is the answer?
Minus 5 root 2, sir.
Is it right?
Yes, sir.
That means minus says that our assumed direction is wrong.
Yes, sir.
In which direction we have assumed? Tensile. So instead you can say this is under compression and this is under compression.
Tens.
Now from point B, I found this. Now at joint A, now how many unknowns are there? Already I know the horizontal reaction is 0.
Yes, sir.
FAB is
1,
known.
2.
What is the remaining unknown?
Oh,
FAD and then support reaction.
reaction. Vertical reaction. RA.
Can I find or not?
Yes, sir.
Fine, sir.
We can. Similarly,
Yes, sir.
if I know the FAD, what about portion member DC? This we have already discussed in the previous class. If two
Equals-
members are collinear, see,
Yes, sir.
that means if this is known, this is also known.
Yes, sir. Yes, sir. Yes, sir.
Problem is solved or not?
Solved, sir.
Yes,
Now,
sir.
is there any need
Yes.
to find the support reactions first?
No, sir.
No, no, sir.
So that means what is the logic here? Like you just have to look at each point to point and then you have to clear.
Clear, sir.
Now, what is another way of solving this? This is what one way of solving, right?
Yes, sir.
Is this a difficult way or easiest way?
Sir, it is time consuming and difficult way, sir.
Why? Because you have written these equations.
Yeah.
Now tell me, without writing these equations, or tell me, is there any way to avoid these equations? In the same process, we'll do the same process, but can I avoid these equations?
How,
By taking
sir?
moment, sir.
Can you apply any sort of some theorem? Think about any sort of some theorems.
Sir, Lam's theorem we can. Not
Yeah.
possible.
Not possible. Why? Because how many members are connected here?
3.
4 members.
4, 1, 2, 3, 4. 4.
Okay.
1, 2,
What is
3,
Lam's
4,
theorem?
sir. 3 only possible.
What is Lam's theorem? Let us say this is F1, F2,
1, F2,
F3, alpha, beta,
beta,
gamma.
gamma.
Now, what does Lam's theorem says? Can you tell me?
F,
Let us say this point is A.
F1 by alpha. F1 by alpha. 3 coplanar
Come on, anyway, others can also try it. What does this says? If point A is in equilibrium,
Yes,
If
sir.
point A is in equilibrium, then I can say F1
F1
divided
by
by
Sin alpha.
sine of
Alpha.
which angle I should consider?
Alpha, sir.
How can you say it in words? If I write it here beta,
Opposite by hypotenuse.
do not completely say opposite. Just think that if you are talking about F1, then take the included angle of other two forces. What
Oh.
are the other two forces?
Alpha
F2
plus
and
beta.
F3. F2 and F3. What is the included angle between them?
Okay, sir. Yes, sir. Alpha
If,
1.
if you guys are saying it in opposite angle, if they
Yes,
are
sir.
not completely opposite, then you guys might have confusion. Like if I represent a force simply like this, one is this, and there is this, and there is this.
I don't know clearly concept, sir. But,
No. That's fine. That's what our even when I studying BTech, that's what they told. Of one
Yes,
by
sir.
sine of opposite. But to be in a clarity, included angle of other
Yes, sir.
two forces,
Yes, sir.
sine alpha, that will be equal to. If I am talking about F2,
F2
what is the
included
other two forces? F1 and F3.
F1 F3.
What is the
So
included
sin beta,
angle?
sin beta, sir.
Sine beta. That will be equal to F3
F3.
divided by
F1 and F2
F1
included
and
angle
F2.
sin
What
of
is the
sin
included
gamma,
angle? Sine
sin
gamma.
gamma, sir.
Let me remodify the forces at joint B and let's see whether it will work out or not. At joint B, upward is acting 10 kilonewton, downward is acting 10 kilonewton. What is the net force direction?
Sir.
What is the net
Downward.
force? Downward. So let me say that. What is that magnitude? 10 is upward, 20 is downward. What is the net value?
10.
30 minus 10, 10, sir. 10.
10 downward, isn't it?
Yes, sir.
That's
Yes, sir.
And this is what our initial representation. This is what our force in member. Which one? B and
FAB.
B.
AB.
Yeah, AB or BA. And this is what our force representation. Right?
FBE.
FB, E, CC. Right?
Yes, sir.
What about this angle?
45, sir.
45. What about this angle?
45.
This is also 45, sir.
What about this angle?
180 plus
Total 360. 360 minus
270,
90.
sir.
minus 9, 270, sir.
Now, if I talk about force in member BA, what about other two forces?
Sir,
FB.
BFBC at
FBC and 10.
10
What is the
included angle
included angle
45,
between
sin
them?
45 degrees, sir.
That will be equal to, if I talk about FBC, what about other two forces? FBA and 10. What is
FB
the
and 10,
included
sir.
angle between them? Included angle.
B and 10. 45, sir.
sine 45.
That will be equal to 10 divided by. If I'm talking about 10, what about other two forces?
Sin,
Sine 270.
sin
FBA and
270.
FBC.
270.
So this is where I tell you, you cannot take 45 plus 45. Included
FBA
angle.
and FBC. So
Included angle is
totally 270.
270. What is sine 270?
180.
Minus 1, sir. Minus 1.
So can I say, if I take these two, what about my FBA? 10 by sine 230 times, sorry, sine 270, sorry.
10 root 2. 10 root 2, sir. Minus 10 root 2.
Then FBC also, both are same, right?
Yeah,
If
yes, sir.
equal
Yes,
and
sir.
if
Yes, sir.
equal,
Yes, sir.
then
FBA equal to
FBA
FBC,
will
sir.
be equal to FBC. Sine 270 is how much?
Minus 1, sir.
Others, I don't know what is sine 270, sine 90, I don't know. Sine 270 is minus 1, is it right? Pin drop silent.
Sir, it is minus 1, sir, but I used
Minus-
calci here.
I also used to
You are
calculate, sir.
saying minus 1,
Sir, I used to calculate, sir. Yes, sir.
but those things should be known.
Yes, sir.
I just say it in a funny way. No. Those standard values we have to. There
Yes,
is no
sir.
other way. Okay. So that will be equal to minus 10 times Sin 45. Sin 45 is how much?
1 by root 2.
How much it will be then?
By root.
Is it right?
Yes, sir. Yes, sir.
Getting the same answer.
Yes, sir.
That means now tell me. Now it's easier or difficult?
But too easier, sir. Very easy.
It's easy, right?
Sir.
Everybody agrees with it?
Yes, sir.
We know
Yes, sir.
minus's direction is wrong. Now tell me, I have assumed it as a tensile force, isn't it?
Yes, sir. First of all, we are using tensor.
What if I assume them as a compression?
Yes, sir.
This
Because
is what
minus.
my 10. If a compression, I have to draw a line. I have to represent this force. What is the force in member? BA, as far I remember. And this is what my, again, one
BC.
force,
BC.
FBC. This angle is 45, this angle is 45. Again, can I write the same equation? FBA by sine 45, that will be equal to FBC by sine 45.
45 degree.
That will be equal to 10 divided by sine 270.
Sir.
Can I write?
Yes, sir.
What about others? Anita said yes. What about others? Yes, Ramya?
Yes, sir. Yes, sir.
Yeah,
Yes, sir.
Ramya is also said right. Vinod?
Yes, sir. Yes, sir. Right. We can write.
That means what about the final output? FBA will be equal to, FBC will be equal to.
Minus 5 root 2.
Yes, by root 2.
Here
Minus
I have
5.
considered. Here I have considered that initially they are under tension, isn't it?
Yeah.
Then what is the
Yes,
final answer I am getting? Minus
Same.
5 root
Minus
2.
5 root 2.
What does that minus represent?
Compression, sir.
That will be
Towards
compression, sir.
Compression. Now,
Yes,
what
sir.
is the direction I have assumed?
Compressive.
But what is the sign I am getting?
That will be tensile, sir. Tensile. Hey, no, not sir. Not so sorry, sir. Sorry, sir.
Where we have committed wrong here? Then.
Sorry, sir.
Yeah, it's fine. Where we have committed the wrong? Can you guys identify
Will
it?
not come, sir.
Yes, Samya?
Minus
Should
will
we
not come, sir.
represent, sir, should we represent the forces along the directions?
No, there is one where.
For example, FBC is towards the left side. So should we represent this is minus sign or what?
No. That's what. What is the application? If you want to apply the Lamis theorem at a joint, either we have to consider either all tail forces should meet or heads of the forces should meet. Here, see, all the tails of the forces have met, isn't it?
Yes, sir.
Even FBA, 10 and FBC. But what happened here?
Here,
Not same, sir.
it is
Is it
meeting
same?
on two head and one tail.
FBA head is meeting, FBC head is meeting, for 10 tail is
Tail.
meeting. That means we cannot apply. Always remember, if you are applying the Lamis theorem, always remember that either tails of the forces should meet or
Head of the
heads of the forces should meet. Then, if I assume them as compression, then how can I solve it then? What is another way? What I can do? I just extend this force FBA such that instead of head is meeting, tail should meet. Initially, where is the force here? This is what your force, isn't it?
Yes, sir.
That means what I will assume, instead of meeting at the head, I will represent the line of action of the force here. What happened? Instead of it is meeting here, now it is meeting at the tail. Similarly for FBC also, I have extended it along to the line of action. Now this is what my member force BC. This is what your member force BC. Sorry, did I wrong? Yeah, this is A. Now, can we apply the Lamis theorem or not?
Yes, sir.
Yes,
Why?
sir.
Because all the tails of the forces are meeting. Now, if I want to rewrite as a heads of the forces, this is what my force in BA, and this is what my force in BC. If I want to take that all heads of the forces should meet, which one I have to change? 10. For 10, what is happening? Head of the forces meeting. To make it head of the forces meeting, then what I can do? I will represent like this. Along the same line of action, I will pull it back. Now all the heads of the forces are meeting or not?
Yes, sir.
Yes, sir. Yes, sir.
What is happening? If I
Clear.
take FBC, what is the opposite angle? If I take FBC, what
90
about this
plus
angle?
45.
90,
Plus
90,
40.
90 plus 45.
135,
What about this angle?
and 45.
All are 135, sir.
No,
Hill, nothing,
come all
sir.
are 130. This is 45, this is 45, 90.
90,
And what about this? 130.
90 plus 135.
Even
Yes,
in
sir.
this case also same. See, this is
Okay.
90, even I am representing. This will be 135.
Okay.
This will be
135.
135.
Observe
Yes, sir.
these two cases. What is happening? See, what is the angle between FBC and FBA? 90. Even I see here, what is the angle between FBA and FBC? 90.
Same.
That means the representation is different. Either tails of the forces are meeting or heads of the forces are meeting. But the angles will be same, included angles. That's why you'll get the same answer. Now clear about the application
Clear,
of
sir.
Lamy's theorem?
Clear, sir. Clear, sir.
Yes, sir. Clear,
Everybody?
sir.
Yes, sir.
Now tell me here, I don't know Lamy's theorem. I don't want to solve these equations. Now tell me some other ways to solve this problem. Let me redraw the diagram. Forget about all. Now I don't want to go in that way. From B, I forgot about it. Now tell me the other way to solve this problem.
By taking moment, sir.
Moments of what?
Moment at
Moment at,
A equals 0 or C equals 0, that will be considered on the.
That means what you are saying indirectly.
Sir,
Yes, please.
BDs, while taking the support reactions, we can find the forces at C.
Yeah, that's what.
So then we can find the forces BC and DC by looking at the geometry of the figures. AB, force AB equal to force BC. So this is also this
Yeah,
type also we can
yeah.
solve.
Just like in the previous case, we have solved the equilibrium of joint P and joint T. Instead, the finding support reactions are also easy. Why? Because it is a symmetric truss or not? How can you
Symmetric,
say it
sir.
is a symmetric truss or not?
Symmetric,
Yes,
sir.
sir, symmetrical one.
Why? If you fold it at BD, they will attach, isn't it? Imagine if you fold this truss with respect to BD, they will be
Yes,
mirror
sir.
image of each other.
Yes,
But
sir.
the forces are not symmetric at point B10 and at point D20. Now,
Yes, sir.
forget about this 20. If 10 is acting, what about the reactions at A and C?
5.
Everybody will agree?
Yes, sir. Because
Everybody.
symmetry is
Yeah.
symmetry.
Now tell me, because of this 20, what about the support reaction?
It will be changed.
Downward 20 is acting. Now what about the support? Forget about 10 now. Because of the 20, what are the
10,
support?
10, sir. 10, 10, 10.
What are the direction?
One will be downward, A will be downward, and C will be upward, sir.
Why at C will be upward?
It-
If it is 10 upward, 5 upward, fine. If it is 20 downward, then how it will be?
Sorry, sir. Please.
What will be the net direction? One
Net
is 5
direction
upward, 10 is downward. Again, if you add these two, how much it will be?
-5.
Downward.
5
Downward, sir.
The reaction at A is nothing but a. Can I erase these things? Yeah, it's clear already for you. So here it is downward 5. Here it is downward 5. Now at joint A, how many unknowns are there now?
A. 2,
How
3.
many
3,
unknowns
3.
are there?
2, sir.
3.
2.
Already horizontal reaction at A is
Physical
0.
0. Yes, sir. Yes, sir.
Already seen. Now how many unknowns are there?
AD, AB, sir.
You can easily find it out, right? I'm
Yes,
saying
sir.
easily. No need of big equations. Why? Because if you look into along y component, along y direction, how many will come?
2 unknowns.
5 will come and component of FB will come. Right or wrong?
Yes, sir.
Isn't it? Now tell me, this truss you are saying it is symmetric, right?
Yes, sir, it is symmetric.
That means the force in this member and the force in this member is also same.
Yeah, yes, sir.
Similarly, the force in this member, the force in this member is also same. Right or not?
Yes, sir, it's possible.
Now tell me if the problem is over. Now you know the force in member BD. What is the BD? 20. After finding reactions, take the equilibrium of joint. You know this and you know this. After you know these two, as it is symmetrical, this is known and this is known. Problem is over. No need to apply Lam's theorem. No need to go for very big equations. The problem is solved.
Yes,
Right?
sir. Yes, sir.
Clear. Why we are talking about this so many ways? What is the use?
Each problem can be found
Yeah.
out using
It
each.
just, yeah, that is what, whenever you are solving the problem, just think about all possibilities. Then only you guys will try to apply for some new problem. Now, can I ask you, what is another way to solve this problem? Is there any other way then? Still, let's discuss this tomorrow. Meanwhile, you guys will search for the options and let us continue tomorrow. Fine.
Yes, sir.
As of now, today's class, is it okay?
Yes, sir.
Clear, sir.
Excuse me, sir.
Yes, please.
Can you explain again that reaction force about A and C?
5, 5.
Yes, sir. 5, 5.
Right.
5, 5 from?
5, 5.
No. How can we segregate like a 5, 5?
What is mean by superposition? What is mean by the method of superposition? Imagine there is a member, there is a 10 kilonewton acting here. What will be the reactions here? If it is equilibrium, 5 and 5.
Yes, sir.
If 20 is acting here, how much about these reactions?
10 and 10.
If 30 is acting here, what about this reaction?
15 and 15.
Instead, can I say if you add these two, that will be the state of this diagram? Can I say it or not?
Yes, sir.
What is the difference? Instead of directly finding for 30, first I am finding for 10, and then I am finding for 20, and then I am adding. The net value is same.
Yes, sir.
Now, because of 10, upward, whatever the support reactions at A and C, upward 5 and upward 5, right?
Yes, sir.
Because of this 20 downward, whatever the support reactions,
Downward 10 and 10.
downward 10 and downward 10. If we add these two, that is what nothing but our given problem. 5 is upward and 10 is downward. If you add these two, how much you will get?
5 downward, sir.
Don't say 15, huh? 5 is downward.
5. Yes, sir. 5 downward.
5 is downward. That's what I got here.
Okay.
Okay,
Okay, sir. Fine.
okay then. Okay, we'll wind up here. Thank you guys.
Thank you, sir.
Thank you, sir.
Hey, don't
Thank you,
forget
sir.
that before coming to the next class, what you have to do?
How many waves?
Any other
You have
methods
to
to
tell
solve
me.
Yeah, that is
No,
possible.
not how many ways. At least you guys have to tell me one method at least.
Okay, sir.
Solve this problem. Fine. Okay then. Thank you. Thank you. Thank
Thank
you
you,
guys.
sir.
Good night.